You know, the Performance Tour show wouldn't be possible without our wonderful sponsors. So I'd like to take this opportunity to thank Tricentis and QA Consultants for supporting the performance testing and engineering community. I am on a quest. I want to find out how to make software and hardware perform at their peak. I want to know how to make applications faster, better, and more efficient. And while I'm at it, I want to have a little fun. Don't think I can do it? Just watch me. I'm Scott Moore, and this is the Performance Tour. Hello everyone, this is Scott Moore. Performance engineering in the software lifecycle. What has that looked like in the past? What does it look like today? And what should it look like in the future? That's what we're going to discuss on today's episode of the Performance Tour. Hi, I'm here with Henry Steinhauer, and we're talking about performance stuff. Henry, you are a systems engineer, a performance analyst, a senior performance analyst, and you've been working on systems and looking at performance for how long?
50 years.
50 years.
And I'm starting to understand it now.
I think we've got somebody with a little experience here. So tell our audience about you and just a little bit about what you've been doing all this time in IT.
Well, I graduated in '71 from Miami of Ohio, and it's on all the sports pages. There's always Miami, parentheses, Ohio. Yeah,
right.
It's not in Florida. It's just north of Cincinnati.
Okay.
They still have a very good computer course. At the time, I was in it probably about the third or fourth year it was in existence. Queuing theory was something that was introduced even then, and queuing theory is something that is still mentioned, but not well gone into in looking at systems. And I found that's one of the areas that has been neglected a lot, to understand what does this really mean? Why is my system slow? And what do I need to do to improve it?
So I think about today's developer who is developing software on a 2 terabyte drive with how many gigs of RAM, and they're complaining because it takes 2 seconds to do this. We've come a long way. So the topic really today is about how the software development lifecycle some things have changed, but some things are still the same because there's still the laws of physics still exist, and we can learn from the things in the past to apply today. And I'm just wondering, from somebody who has seen it all, and you're still seeing it today, what's some of the biggest changes that you've seen in the lifecycle that affects us as a performance engineer the most?
One of the things is just your usage of data, and one of the concepts is the locality of reference. How near to the data is your processing? Mm-hmm. We're all familiar with CPUs and the fact that there's a level 1 cache, level 2 cache, level 3, level 4, and then finally real memory. Mm-hmm. And then after real memory, you then go to solid state disks. There's a time penalty every time you move to another layer of cache.
Right.
And people don't necessarily realize that there's examples of, if you do matrix multiplication in the wrong sequence, instead of going sequentially through memory, you're skipping. Because of your array size, you're skipping to a completely different part of memory. Consequently, you're getting cache misses when you do that. Mm-hmm. If you go in the way in which the compiler has laid out your array, and you go in sequence of it, in memory sequence, then you're 10 times faster of doing that array processing. And it's a very subtle difference, but speed-wise, it's tremendous.
But do you think today's developer just coming out of school or somebody who's been developing for 2-3 years is thinking of that butterfly effect when they're writing code?
No, of course not.
Yeah, so how do we get them to understand that effect? If I change these 3 lines of code, but I'm not thinking in these terms, how wide that path of effect is. In other words, now if everything's in the cloud, every line of code you write is affecting your cloud bill in a real financial way, where we see financial penalties based upon not understanding those fundamentals.
It's a hard question because we've gotten so far away from the actual machine code to understand what's taking place there. There were options in COBOL, which is, that has come back up into the forefront of conversation. There are options that you can do in that compilation of code to say, show me the assembler code. Show me the byte code that is actually going to be done. I did that in the mainframe arena and was able to better understand how CICS transactions work so that they can have serial reusability of programs. What does that mean? That means that instead of having to get the program off of the disk again to bring it into memory and execute it, I can bring it in once and then allocate all of the working memory in another subspace and have this terminal user, use that transaction while at the same moment another user is using that same transaction, but they have a completely different working set of scratchpad memory, totally independent. They're using the same code, but they're using a different area of memory.
Compare what you see today versus what you may have seen 10 years or 15 or 20 years ago. The types of problems you're having to resolve from those types of tests, has that greatly changed? Was it roughly the same? Is it still, it's your database, it's your code, we don't have enough infrastructure, it's still the same suspects, or is it changing because languages are changing, or because techniques are changing, or because infrastructure is now much cheaper than it was 20 years ago in some, I mean.
That's always been the argument. It is, let's just do a forklift upgrade and replace this stuff with new stuff. And in the old days, it used to be a forklift because it was so heavy. And it literally was, you're going to have an outage for the entire weekend as you swap everything around. And you're lucky if you can get it done over a weekend. Now it's a question of just bringing a new 2U or 8U server and plug it in and switch everything to that IP address instead of this one. But a lot of the issues still are the same. Anytime you go off platform of that particular processing, you're going to be introducing delays. And as we saw in this one example, that even though he was doing all the database calls, there was also a high amount of Java heap reclaiming process going on, garbage collection going on, forced because he was throwing all those objects away. They're now eligible to be reclaimed, and now I'm making a request for more objects, even though they are identical to what I just threw out. The infrastructure does not know it is identical.
Right. So getting back to, I guess, explaining to people, we've talked about Grace Hopper in the past, about how she used to explain to people that may not understand how long something takes, or how this affects this other system. And we had talked off camera a little bit about this, but can you mention about that?
I'll just also give a plug for any of the people who are watching this. Search her name, because she has some excellent videos of seeing this woman who started a lot of the industry and brought women into the industry to say, hey, it's not a boys only club.
Mm-hmm.
You can be here just as much as anybody else.
Sure.
And she proved that in spades.
Mm-hmm.
She's just such a phenomenal speaker. I actually accidentally ran into her at a conference in the 70s. I was in school, and we had a chance to go to an ACM conference. And I had made the statement that there must be thousands of computer languages, and she was behind me and said, no, there's only like 350. I wrote a book about it.
Okay, ears perked up. You have my interest now.
You have my interest. But she was interested in the speed of light, the speed of electricity through wires. How long does it take, distance-wise, to get information from A to B? And she called the engineering part of the Navy and said, I need 1 millisecond of light, of wire speed. Send over a spool.
I can only imagine the person on the other end of the line like, what?
and she went so far down to milliseconds and nanoseconds, microseconds. And she had a 17-inch piece of wire that she then used as handouts to people in her conferences to say, this is how long a particular event is. And right now my mind is blank as to what which value it was, but it was the fact that it was 17 inches long. And one of her admirals was saying, well, why does satellite communication take so long? Mm-hmm. Well, because you have all these 17-inch pieces going out to the satellite and back.
Yes.
That's why.
That's right.
And the same as what we're talking about with the L1, L2, L3, L4, and then main memory, and then going finally to a solid-state disk. You're talking about those distance that the electron has to travel to convey information from point A to point B. And we're still in that process. When we look at the internet, I bring up a laptop and go to the web, and I'm going to a particular site that only has one server behind it. I'm still talking about what is the distance here. Mm-hmm. One of the rules of thumb I'd used for years was 1 millisecond is roughly 100 miles of internet space. And I don't think the numbers are quite as exact now, but it's still very close. Mm-hmm. And even though we're using fiber between major hubs, coming out of that hub, you're still, some places you can have fiber to your house, one gig internet to your house, or 10 gig internet to your house.
So there's a lot of things that I think people who are still maybe in school, in college, in technical school, and they're learning how to develop, they're learning how to build applications, I think there's still some fundamental things that they may be missing. Maybe they're going too fast through these courses, or maybe I think there's another level of education that needs to be there that I feel is missing. Mm-hmm. That's what I've kind of come to the conclusion doing this performance tour and talking to many people, is there's still a level of education in this realm of understanding performance and how things work that just, it's not there, that needs to be there. Would you agree? Definitely agree.
Now, you had mentioned CMG, and I was a regional chairman of the Chicago regional group. We called it the Midwest Computer Measurement Group. Because of a friend who challenged me to pick up the reins of it, I was the chairman from 1980 through 2002. Mm-hmm. And it was a standing joke. No one really wanted the job, but we did have an election every year. Mm-hmm. So we would say, who would like to be the chairman? No one. All right, well, be sure to vote early and often.
Right.
Because we are in Chicago.
Right.
And I had a beautiful board, and one of the people was from the Illinois Bell Company, and the hotel that we were using for this conference, Illinois Bell, used a lot of their facilities. So we always got a really good rate for using that hotel.
Right. That's great.
And But we would have meetings 4 times a year, and vendors would come, and the things technicians and the people in the industry hate is when a salesperson comes in and they're just doing a blanket sales pitch. And I would always say, time out. All right, you've heard him describe the problem. How many of you had the problem that he's talking about? Maybe one hand would go up. I said, the reason I invited you here was I wanted to know about this process. And we had talked about it before, so hopefully you're prepared. You know, let's toss out your canned PowerPoint process and let's talk about this part of your product that solves these types of problems.
The solution.
The solutions.
Right.
And that was always a lot of fun. One of the areas of interest that if people want to explore is an area called queuing theory. Now, the systems of today are built of queuing systems, multiple queuing systems tied together. They're not just one queuing problem. In the old days, one of our first computing queuing systems to analyze would be a gas station. How many pumps do you need to satisfy the flow? How long does it take for someone to pump gas? How long does it take to, you know, pull in, pump your gas, and get out? What is the arrival rate that you see? And we've all experienced the art now of queues from the bank teller, where you come into one queue and you have 4 different tellers. You come into a bank queue where you have 4 tellers, but you have 1 line. And you stand here until someone else is ready for you. The kids may not remember it, their parents may, their grandparents for sure. You used to go into the bank and you made a choice. Which teller line do I want to go into? And you went into Sally's line because you knew her and she was always gave you a smile. You didn't go into the other lines. Now we go into one universal line, and now we're served by all of these people. That's a queuing system. Queue means line, British term.
Right.
And if people understood the queuing processes of when I make a transaction, where does it go to? Where does it go to next? Where does it go to next? What are all of the interconnections that have to work properly for this to be completed? Who else is competing for service at node number 2, deep into the stream? Are you isolated, or is that node being shared by everybody else? Those are the challenges that we have today. The visibility and observability of what else is going on. One of the challenges that I've seen in the industry for years is being able to understand and follow a transaction from all of those different points. How do you tie them together when the call that is made from the app server to a database server has nothing embedded within that call to say this is based on transaction XYZ? Nothing's in that call to differentiate that, because that query call could be done by 15 different transactions or 100 different transactions. What makes this one unique that we need to identify why this is behaving? That's where tools like, and I'll mention a few, New Relic and App Dynamics, both of those are able to capture the SQL that's being done from the Java code from in the app server to the database server. And they can attribute that SQL to that particular transaction.
Right.
But they can't, if you're doing a stored procedure call, they don't know where that's going next. And now that's a challenge.
And how does it get there? And then what's to tell me how long it stays in this particular place before it goes to another place, and why did it stay there that long?
Exactly.
Right.
Those are the challenges we have still ahead of us.
Do you think that's where open telemetry and open tracing and some of these new initiatives, where especially like when they're dealing with Kubernetes-based, container-based applications, we're dealing with things that exist now that may not exist in an hour. As they spin up and spin down containers, this tracing keeps track of where it goes and reports back at each segment of the queue. But do you think that may not be the total answer, but does it help?
It all helps. The question is, does it maintain enough intelligence of the identification of that transaction so that you can associate it with what the call before it got to this call is related to? That's your challenge.
And the biggest challenge for these vendors, like you mentioned, is then how do I visualize that in a way that it makes sense to people so they can quickly identify the problem, quickly drill down, and get to time to resolution.
Correct. Correct.
So still challenges out there. Henry, thank you so much for being on the Performance Tour. It's been great.
And you may ask yourself, can I reduce that large cloud bill? And you may tell yourself, this could be a very good app. And you may tell yourself, this could be a very good site. Letting the days go by with performance testing done. Letting the days go by, defects slowing every day, making it great again. After the testing's done, once in a load test helps your application scale. Slow as it ever was, 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 slow as it ever was. Performance testing, performance tuning. There is always testing needing to be done. Test and monitor, always monitor. Metrics, logs, tracing, that's the key. Let the days go by with performance testing done. Let the days go by, no more defects flowing out into the black again. After the testing's done, once in a load test helps your application scale. Fast as it ever was, 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 fast as it ever was. That's the key. I was